Hello and welcome back to another episode of Getting into Good Oxide. Welcome back, Sydney.
Hi, Sebastian.
I hope you all had a nice weekend because now we continue with prefix lookup in packs maybe. This one, yeah.
Yeah, exactly. I think we successfully implemented the lookup prefix function last time, right? I think everything worked, if I remember correctly.
Let's check. The test should be able to help us along with that. And as always, the tests do run. Nice. Let's put that back in its place. Okay. And I think since last time, I only did small refactorings here, which were all suggested by Clippy. It's all about the collapsing of the nested if conditions here. Last time you already helped or was it this? No, I think you mentioned it elsewhere. But Clippy had something to say about this and just said, okay, here, I collapse all of this. And I did.
Yeah.
And now
everybody's nice.
Happy. Yeah, it's a bit more concise, even though not everyone might be happy about the line length here. But I'm happy with it. It's okay. Only in presentation mode, it's a bit tight. So, there's multipack here. This is in multipack access. And now the same thing should actually apply to the standard pack. Because they're very
okay. So that's what we continue next. So we implement the same function for the different storage method essentially.
Yeah. That's right. I mean, here I think that's the best overview we have. Bunch of checkboxes. This one definitely working. Now the same for pack, and yeah, that should be a quick one. And relatively simple, but it's mostly boilerplate for us because maybe copy paste a lot of similar looking tests because they are quite applicable. So test-driven development, I think. If you have to copy paste test, then that becomes very easy, at least in theory. So IntelliJ, are you gonna show me the corresponding tests this time? Yes, you do. Multi-index. Yeah, I'm thinking that this module here is now also big enough to be factored out. So maybe extract this inline module here. Now we've got a new file that contains all the access related code, which also contains our lookup prefix code, and from there should be able to copy paste a few over to the other tests. So, and you see how usually these modules they follow the directory structure here. So ideally that's all the same: multi-index, write, verify, access, and so on. So that's the idea, and that in turn mirrors the things they test, so that it's relatively easy to go from one to another just by convention. And it's probably not the case everywhere, but it should be. That's the aspiration. Okay. Lookup misses. Oh yeah, lookup missing. So that seems to be a good one to get started because that would force us to implement at least the basic API also for the standard index. Okay, so in theory, following that rule, I should be able to find index-related tests. And they seem to be in a single module here. And it's organized a bit different. We have index file. And then there is lookup, v1. Oh. And GiG-22 lookup. Is that really different? So let's see if it's different in code. So about, I mean, I guess that's just short history about Git indices. There's a bunch of versions of it. V1, V2, and by now V3 maybe even. Is there V3? No. V1 and V2. And they're organized a bit differently when it comes to the layout on disk. But the question is really, does that truly affect the lookup code or not?
Mm-hmm.
And we see that there's only one lookup here that is called from both, and there's no check for the version here. So that appears to be general. Here,
it looks pretty familiar.
Yes, true. It is the same thing. It was the same thing. And you see, I just copied this over without even trying to unify this, because somehow I thought, I liked it so self-contained. I liked it. It fits on a screen even in presentation mode. And of course, that attitude, it bites you once you want to improve on this one, and you then forget the copied version that is elsewhere. But yeah, let's just say it's obviously perfect, so no need to improve anything. But in theory, you could. But if you think about it like this, like if you wanted to improve this, then you have to, put a closure maybe for this one, and that adds a little bit of, just a little bit of additional complexity, which I probably avoided. But now that I say it, when I talk like this, I think that there's only one way of thinking about this, which is kind of, hey, Sebastian is a bit sloppy, isn't he? And the answer is yes. But when I realize this myself, then I say at least there should be a comment that says, this index file lookup. So maybe the same node there, and then I feel better about myself. Yeah, it's amazing through how many iterations of file formats Git has gone over the years and changes, and you have to support it all. But yeah.
Of course.
Yeah, back to index. Okay. Then, in case I don't have it anymore, let's copy this. Get to the pack index test. Is there something that I want to factor out right away? Because that looks a little big. File. And you see there's this top level module file that really spans everything, and we don't have that in multi-index anymore. Like here's just multi-index, and then it's just assumed to be a file because yeah, it's always the file that we talk about when we talk about multi-indices. They don't exist as something else. So even though that's more precise, I think it's okay to cut this out. And then we have method here, 200 lines, method lookup, method v1, v2. So because there's the separation, I guess. In version 1, version 2, there's this kind of thing going on. Okay, I don't feel comfortable to change names here. Let's see where lookup is called. Let me just find a nice place for what we actually want to do now. Pack lookup. So here we run lookup. So it looks like here in method v1, method v2, there is these lookup functions. And I think looking at the code that whether it's v1 and v2 doesn't matter, because that code works, it's well tested. I would want to avoid duplicating the prefix lookup code everywhere in v1 and v2, but I would be okay doing it if it's not too much. Like a quick call here, for instance. Maybe just create a prefix or something and then do a lookup prefix similar to the other places and just copy this over just to call this thing. I do have loaded. Oh. I should still have. No, I don't have it anymore. I don't have my test. I have to copy it again, maybe this time proper. Yeah, let's just find a spot for the missing. Yeah, it's probably in any, so any version. It's more a version here, version v1, v2. I think then it makes sense. And any, because the tests here in v1 and v2, they use different indices with different versions. And I think they're more or less of the same, but the idea is to just be sure that it actually works the way we think it should.
Yeah.
This is why it's split up, even though technically under the hood it can hardly go wrong because of the way the code is organized. Like the actual split is only visible to very low level short functions that you can, get right more easily. So the higher level ones, the longer ones are not a problem. But anyway, assert index right. This was one of the first thing I wrote. So I'm not so happy with the method names here, but I think this one is just called elsewhere here. Yeah. So here's a test, and assert index right is apparently only used once. That's interesting. But nowadays, it's really interesting. Like, why would I factor this out? Don't know why I factored this out. But in any case, since it's only used there, I would definitely put that back in here where it's used. And just put this in here. And now it doesn't bother people that just look for a nice spot for the next test to write. Yeah. And you see, like, maybe as a general attitude, if something feels off or it seems harder than it should, then take the time to refactor a little bit until it's a bit easier.
Yeah.
Which probably is easiest if you've written this yourself, but in a way, everybody should be able to find a spot. And this one is a bit, not too bad, but probably worth improving. Yeah, okay, back to finding a spot. So we already had any, and there seems to be only one test here. So let's put it below, look up missing. And here we go. First test, which should fail. Oh yeah, multi-index, we don't have that. Let's get some index. Where do I get an index? Look at that. So there is, I think there's a function to get an index here. Oh my God. This is too complicated. There must be an easier way. Here, index file at fixture pass index v2. Let's do this. Let's copy this. This is coming from lookup v2, so that kind of makes sense that this is a bit simpler than the stuff I do further below with the writing, whatever that is. Yeah. Okay. index v2 and SHA-1. Yeah, that might be, I mean, probably the same thing happened already with the multi-index. Yeah, that's the file. But it's important to note that these file formats themselves, the index file, it doesn't know what kind of hashes are stored in it, because the file format back then only assumed that SHA-1 will be good forever, because obviously 640K is good forever, right? So it's the same fallacy. And if you think about it, SHA-1 is so good, of course it's working forever. But yeah, compute power is the factor here, I guess, that breaks every hash. And that's always going up. So yeah, these are parameterized, so you have to tell it what kind of hash is stored, and Git usually stores that as part of the repository configuration. So first...
Yeah. So it doesn't mix, right? There's only ever one SHA kind in the repository.
Yes, there should be, but technically there doesn't have to be. Like if somebody wants to mix, sure, but this will confuse things, because yeah, you read this one value out of the config and then you pass it here, and if that doesn't match up, then you can't read the files and you will not get far. But yeah, no guarantee it's consistent. Too many files that rely on this. Okay, so now we build a prefix of null that is definitely not there. Also SHA-1. Yeah, default should always be SHA-1, but I feel better by just mentioning this here. And now we can try it, and it should be none, and tell us that this wants to be unwrap, and now it should work. Cool. Multi-index access. So let's see if that works. It could work, potentially. Okay, here's lookup right below. I dump lookup prefix. Let's see. Given prefix, find an object that matches uniquely within this index and return entry index. It's the same thing. I mean, it's an index. Oh, I dumped it in the wrong file. Index access. Here we go. Okay. Lookup prefix result. It's in create index. This is even ours. That's nice. Okay. Yeah. Look at this. I mean, except for a few imports, it's really, really similar. And who would have thought otherwise? I mean, in memory is literally ordered hashes in a row in both indices or index types, the same thing. And we're lucky enough for these APIs to be consistent, because why would they not? So yeah, it's the same thing. And it should just work.
Yeah.
It compiles. Oh yeah, I'm running the right test. I'm running lookup missing, and it does work. That's a bit boring. Okay. Yeah. It's harder to find the right file with the test than to actually implement this. So yeah, lookup missing works apparently. Yeah, I mean, I guess, you know, if you have tests that are green immediately, you should always wonder, could there be a problem with the test? We copied everything. So probably not, but I would feel much better if I had a positive test as well. And for that, yeah, let's take V2. Here we know a few indices which do exist, but also, look, it has this index here, this index file. And it has two portions of the test. First, it does a lookup with known indices. And then it does a lookup just, in a general fashion. And in theory, in each of these cases, we can just insert our partial prefix and,
the same.
Make something up, yes. We can specify the hex length just for fun. We have 3 options here for the hex length. So shortest one, I just make this up. Shortest one is 4. That's the last object in the pack. We could go with, I don't know. Yeah, hex length 40, because that's all short one. So one of these explicitly, and then maybe 7. Oh, that's not in pack. Oops. And here that's the desired assertion, so that's supposed to be none. Can probably make use of that. Assertion that's expected. Okay. Yeah, maybe assert is okay for this, for starters. Always a good test if you can remember the API after a weekend. So far, so good. And I have to unwrap this. No, we can question mark out of that. And then we want it to be expected. We can probably map this. Hey, expected is an option. I should be able to map it. It's just IntelliJ, am I right or is IntelliJ right? I don't know. Let's just say I'm right. I can map the index and it's an okay, right? Because if there is something that's now wrapped into an okay, it should always be there. So I should be able to do this, map okay, and now we have the right type. And then I can do assert equal. And this is, yeah, just that. That should be working. Let's see. If we pass expected here. All right. Oh yeah. Oh, desired index. I got that wrong. Assertion. So that's an assertion message. Let's see. So my naming was misleading. Misleading enough to fool me now, and now this is actually expected. And it might still not work because this is not owned. This is borrowed. So I think I have to do it like this, but yeah, let's see if the compiler tells us something. Oh, interesting. Ah yeah, this is a hex. This is not an ID yet. So we want to use this. Okay. So that works. Now the same thing here, I guess. Just look up the ID again, and then it should be a match. So the index we get here should be the same index that we get for a prefix search. And then we can probably, alter the hex length to not make it static like before. Maybe. Okay. Entry index modulo 40, actually modulo. What's our hash kind? Hash kind SHA-1. I should probably give myself a little bit more space here. So hard. Lang and hex. And then the opposite of what you think. 7. Okay. Now we have a hex lang that gives us a prefix. Of the entries or ID, and that should give us an index that is exactly the same as the one above. Expect object exists, expect non-ambiguous. Yeah, and that needs to be question marked. Okay, that should still work. And it seems to be working. Okay. Yeah, I mean, we call this thing. It's still, no red test ever. Is it actually running? Can I botch this somehow? Lower bound, mid. Oh yeah, okay, now it's an endless loop. So clearly that was not the right way to botch it, but it looks like this code is called, and it definitely does work. Okay, there's probably other ways to do that without causing endless loops. But yeah, and I guess this part here, I can now just copy paste that over to the V1 version.
Just to have it there as well.
Yes. That pack might also be, it's a bit bigger, 65 inch entries, but overall these packs are very small. Fun fact, they're still from times of GitPython, sometime 12 years ago or something. I found these, or I created these, I don't know what the source is, but since then these I have been dragging around. But now,
perfect for testing.
Yeah, actually not, because they're magic. You don't know how to recreate them. You don't know where they are from. All you know is, I think they are from the GitPython project even, but I don't, I would have to check what's in the objects. I think they're mine that I created by hand somehow, but it's not reproducible and not nice to have. It's like, okay, that's what Git Oxide started with. Back then I didn't have the test capabilities that there are now with, where is it? Yeah. I mean, you write these scripts that are executed and then just shell scripts, and they produce using Git the kind of files you want. And that's a bit more involved usually because you have to configure Git accordingly, but it's usually worth it, as then it's definitely reproducible. Using Git to produce files to test Git Oxide, it's great, right? To have this truth, a source of truth that you can rely on, that you assume is never breaking you. And that's a fair assumption in case of Git, because they really pay attention to backward compatibility. So now v1 lookup. All right. Entry index fail is missing. Enumerate. Okay. Now this should work a bit better. No. Object hash. So you see, it's basically a copy. Now I redo the work, but I don't find it particularly terrible somehow. It's okay. One could, I think now that we are doing this, it's worth it to realize that this part here is very general and could be generalized. Like this iterator over entries, this is equivalent. It's the same thing in both cases. This is specific, but the other stuff is not. This one here, that's a copy paste. So I really, like in version 1, so to say, I'd be okay to just copy paste this, but as an extra factoring step, I would then factor this method here out. And because is it the same? Yeah, it is the same. Also the CRC checks here. It's a bit different, I guess, but they do the same effectively. See, here there's no messages in the assertions. Here there is a message.
Right.
Yeah, but besides that, I think it's the same. Okay. Does that work? Yeah, right. Renamed this one. And now it should work. Yeah.
Nice.
Well, and that's it. Now there's prefix-based lookup also in normal indices, and that's a big step towards supporting this as a whole. I guess halfway through, or maybe 1/3 through, because the work needed for this, I think it's relatively straightforward, and at least the same amount of work, if not more, I would expect for this. Let's see, also ODB can be a bit more involved. Even getting into that code is a bit more involved to bring it all together. Shouldn't be too complicated, but it's definitely something that you can spend some time talking about, because the ODB is a complex thing, and yeah, even Rust won't protect from bugs here, because it's all about concurrency and making it as concurrent as possible and as fast as possible while being concurrent, and then you have to reason with your own brain's logic, and you know how that goes usually.
I assume that there's already like a lookup function in place, right? Like very similar to what's already there in multipack and the pack index. Isn't that the same kind of concept where we just kind of extend the functionality that's already there? That might help us a lot, I'm guessing.
Yes, I don't expect us to have to solve concurrency issues from scratch or anything like that. It's more like do the same thing again. You are totally right. But I will probably have to talk about what's going on there a little bit at least. And then you see it's a bit of a rabbit hole, and I'm curious. Let's see what happens when I try to do that. It's probably going to be fun. But first, loose object database. That's also going to be fun, but I guess that is for tomorrow.
Sounds good.
Great. Then thanks a lot, everybody, for watching, and see you tomorrow. Thank you.
Bye-bye.